Hello, this is Garrett Keane, and today I'm going to present a video showing how to get the solution for a four-sided traverse. This question here, this four-sided traverse, was given in a 2014 paper to the DT004 Year 2 group in the Surveying and Levelling 2 module. If you look at the four-sided traverse, what you're actually given are four measured angles, internal angles. You're also given for the line A to D running from here, and this is your north direction here. You're given the forward whole circle bearing of 193 degrees, 10 minutes and 12 seconds. So that's saying the clockwise angle from this north direction, if you come around that way, is 193 degrees. Also, what you're given here is the easting and northing reference point for point A for the starting point, and it's 200 meters east, 300 meters north. So that's your coordinate of first point A. Once again, the angles are repeated down this table here, but also what you're given are slope distances between the stations and a zenith angle. So you're not actually given the horizontal plan distances, you have to work those out from these figures here. In total, what you're asked to do is 6 different steps. First step is the horizontal distance between stations, as I just described, and that's the first thing I'm going to cover in this video. Steps 2 to 6 I'll cover in subsequent videos, but if we just go over them quickly, you have the angular misclosure at the surveying adjusted angles. So what you're basically saying here is you have your 4 internal angles here. This is a four-sided traverse, so they should theoretically add up to 360 degrees. If they're either too bit short, if the sum of the 4 angles is greater or slightly less than that, you have to work out what the error actually is and then distribute it equally between the 4 angles. Then you need to work out for steps 3 to 6, you're provided with a table here, a blank table, and on the left hand side you'll work out the whole circle bearings for each of the 4 lines of the traverse, which will then go into here. Use this space to work them out, and then you put them into here. You'll also have the corrected horizontal distances, they'll go in here. And from those then you can then work out the next steps, which are basically the partial coordinate differences. They will fit into these 2 columns here, this column here, this column here. You'll find that they probably won't be perfectly correct. There'll be a slight misreading at the end here. And what you then do is you apply the Bowditch method to adjust for those. When you have the adjusted partial coordinates, delta E and delta N, they go into these columns here. You then, from your starting value of 200 and 300 here, you will then be able to work out the easting and northing coordinate of all the 4 points. Okay, that's a quick overview of what we're going to do. I'll just do the slope distances one first. So if you look at it here, these are the slope distances between the 4 sides, and this is your zenith angle. You see in the illustration here, the zenith angle is when you level your theodolite. The zenith line, the line here is an imaginary line that goes up perpendicular through the level theodolite. Your zenith angle is the clockwise angle measured from this line. So if in this illustration is 74:30:00, your vertical angle is the angle measured from the horizontal line running through here, which is perpendicular to this imaginary zenith line. And in this case, it's a positive angle here. If it's clockwise, it's 90 degrees. If the angle here is less than 90 degrees, you subtract this angle from 90 degrees and you get a positive clockwise angle here. If, however, the angle is greater than 90 degrees, your angle will be down here somewhere. And what you then do is you subtract your angle, like this example up here. You subtract 90 from this, but the angle is a negative angle, so it will be recorded as a negative angle. So there's basically 2 rules involved. If your angle is less than 90, you just subtract the angle from 90, and that gives you your anti-clockwise angle measure from the horizontal. If, however, your angle is greater than 90, such as this one, you just subtract 90 from this angle here, but the angle is negative because it's going clockwise relative to the horizontal angle. So if you want to pause the video for a minute and try to work those 4 out before I reveal the answers. Okay, at this point I'll reveal the answers, assuming you've had a go at trying them out for yourself. So the first angle is 90 degrees minus this. So if I reveal this angle, it's 0, 57, 20. So if you say 40 seconds plus 20 seconds, that adds up to 1 full minute. Then we have 57 plus the one that we carry is 58 plus the 2 adds up to a full 60 minutes, which is 1 full degree. And that 1 full degree gets added on to 89 to give us exactly 90, which is correct. So if I refill this one, we said we subtract 90 from this, but the angle is going to be negative. So that's much easier to work out. It's going to be -1, 45, 30. So if I refill it, you can see it's -1, 45, 30. Likewise, this one is easier to work out because you just subtract 90 from this figure here and you make it negative. So that gives us -2, 16, 20. This one is less than 90, so we have to subtract this from 90. So we'll get something like 34 in here, 24 there, and 1. I'll just check it now. Yep, 1, 24, 34 is what we get. Okay, the next step you have to do, and if you want to pause it, is to get the angle, the horizontal angle. It's basically the slope distance, which is this distance along here, multiplied by the cosine of this angle in here, whatever the vertical angle is. And that will give us the corresponding horizontal angle. So it's basic trigonometry. So if you want to pause for a second, work out the cosine of all these angles. And remember, the cosine of a negative angle is the same as the cosine of the equivalent positive angle. So if you pause it for a sec and then work out the cosine of these angles. So give that a go for a second. And now I'm about to reveal it. So the cosine of the 4 angles is given here. And you can see that they're virtually 1. The cosine of 0 is 1. So all of these are very close to 1. Now once again, if you want to pause it and you want to work out the horizontal distance for the 4 distances, it's basically this. For this first one, it's the slope distance here multiplied by this figure here, which is the cosine of the vertical angle. And you can do that for all 4 of them if you so wish. So if you want to do that, pause it, and at this point I'll reveal the answers. And you can see that the answers have come up here. So basically 112,635 is got from multiplying the slope distance by this figure here, which is the cosine of the angle, which is the angle in here, the vertical angle. Okay, so they are now our corrected angles. And what I'll do with those is that they will get transferred across to our sheet, onto our sheet over here. They'll get transferred automatically into these 4 spaces here. That's the distance from A to B, that will go in there. Distance from B to C goes in there. Distance from C to D goes there. And distance from D to A goes there. Okay, thanks for listening. I'll continue on the next one, which is to look at the angular misclosure. Okay, thank you.